Airline flights that come and go day after day, often year after year, without fatal mishap, tend to obscure the importance of constant preparedness, a preparedness that would count in lives if ever the day were to come when seconds would separate life from death. The routine job of the cabin attendant, whether steward or stewardess, is to make the passenger's flight as comfortable and enjoyable as possible from the time the passengers board the aircraft until they reach the arrival gate. However, their most important duties are performed in cases of emergency. The probability is that these cabin crew members will go through their flying career without ever experiencing a real emergency. But should such an eventuality occur, it is often with great suddenness. It is vital that the cabin crew perform their allotted duties correctly and with a well-drilled accuracy that can be acquired only by constant training. Now, going back in time, we will see how some of this training was undertaken. This is no ordinary classroom, nor is this an aircraft, but rather it is a simulator for emergency training. While it is obviously beyond the scope of this film to deal with all the equipment and procedures which differ from one airline to another, the film will show elements of the practical training given by one typical international airline. International regulations require many kinds of emergency equipment to be carried. For flights over large bodies of water, a life jacket is provided for each person on board. Life jackets are always stowed where they are quickly available, often in pouches under each passenger's seat. These jackets are designed to be reversible. Regardless of which way they are put on, they will work equally well. Although the design of life jackets may vary, they all have many features in common. The jacket is divided into 2 air cells, and for each of these, there is an inflation cord which activates a CO2 cartridge. To aid in locating the wearer at night, there is attached to the collar of the jacket a rescue light which operates from this water-activated battery. All that is necessary is to pull the tab so that water can enter and activate the battery.
Even de label eraf trekken, want als u dan in het water komt, dan gaat dit lampje branden, zodat u in het donker altijd kunnen vinden.
The cords must be given a firm pull to pierce the cartridges and inflate the jacket. On the inner side of each half of the jacket is a tube to permit the jacket to be inflated by mouth in the event that the mechanism fails. And there is also a whistle to attract attention. Life jackets are designed to support a person, even when unconscious, on his back, face up, out of the water. Due to this design consideration, they are not convenient for swimming. If it is necessary to reach a life raft, swimming on one's back proves most effective. Life jackets should not be inflated inside the cabin. This tends to hamper the movement of passengers and makes evacuation through emergency exits difficult.
En dan aan de voorkant weer, ja, daar, ja. Oké. En dan ietsje aantrekken, hè. Er zit dus een slipje aan, hè. Die was niet te strak natuurlijk, hè. Gaat het? Ja.
Moet je het hier weer wat vastmaken?
Oh ja, nee, dat is goed.
Exit doors are heavy, and therefore, in an emergency, where time permits, the crew should ask passengers to exchange seats in order to position a strong man in the seats next to emergency exits. A belt must be worn by this passenger, as he, or she in this case, will be required to open the emergency exit and to step out onto a wet, slippery wing where high seas may be encountered. The snap on the ditching line is fastened to this anchor point below the sill of the exit. It must be remembered that exits cannot normally be opened until the cabin has been depressurized. Crew members should be given a chance to become familiar with handling these doors to better appreciate the difficulty they present. The door can either be placed on the seat if there is room or thrown out if necessary. The person assigned to open an emergency exit must be carefully informed that he must not open the exit until he has been given the signal to do so by one of the crew members. Nervous passengers might attempt to do this at an inappropriate time, thereby jeopardizing the safety of all on board. In addition to life jackets, regulations also require that one or more life rafts be carried on long-range over-water flights in sufficient numbers to accommodate all persons on the aircraft. In this instance, the overhead compartments house various survival gear, including the life rafts. Doors to the compartments shown here have retaining straps. There are 3 of these straps, and they are arranged to break open one after the other as the door is pulled down. A life raft pack with its survival kit weighs about 75 kilograms and must be removed with sufficient help. It is important here as well that trainees be given the chance to actually remove a life raft from its compartment so that they will appreciate just how heavy it is. The inflation line is unfastened and given to the person waiting on the wing, who in turn will fasten it to the ditching belt. This precaution is taken to prevent the raft from being blown away. The raft is then lifted through the exit onto the wing, where it will be inflated and launched. Whenever possible, life raft drills should be carried out on water to give trainees a more realistic appreciation of the problems they would encounter. Otherwise, they should at least have the opportunity to see a life raft being inflated. At first appearance, it would seem that the cartridges used to inflate this raft were insufficient to completely fill it. However, this is not the case, since inflation will continue slowly until the raft is firmly inflated. The inflatable canopy support is next attached. This brightly colored canopy serves to both attract the attention of rescue aircraft and provide shelter from sun and rain. Here again, the inflation time is slower than one might expect. This is normal, however, and gradually the frame becomes rigid. In a pack inside the life raft are various items for survival, often including packages of emergency rations and drinking water. There is also an inflatable center post to support the canopy in the event of high seas or rain. Usually, 2 radio survival beacons are stored separately in the aircraft and must be taken by crew members into the life rafts. The beacon is fastened with a line to the life raft to prevent it from drifting away. Before putting the beacon into water, any cellophane wrapping must be removed to allow the water to dissolve the tapes freeing the antenna to swing into the upright position. The beacon will float right side up in the water and transmit automatically. The beacon may also be used on land by putting it in a plastic bag containing water. Portable oxygen bottles are carried aboard aircraft primarily for the purpose of administering oxygen to individual passengers should the medical need arise. The person receiving oxygen and anyone occupying adjacent seats must not smoke while oxygen is being administered. The captain must be advised as well when oxygen equipment is used. When given for first aid, the high flow position should be selected. The connector must be pushed firmly into the socket. The control valve is turned counterclockwise. On units that are equipped with a flow indicator in the hose, a quick check will determine that oxygen is indeed flowing to the face mask. The face mask must be placed firmly over the nose and mouth of the passenger, and, if necessary, the mask can be held in place by an elastic band which fits over the head. With the mask fastened in place, the passenger can be left on oxygen for as long as is deemed necessary. When you are finished with the unit, be sure that the oxygen is turned off fully and that the mask is folded up and replaced in the pouch. Make an entry in the log and indicate which unit it was. In DC-8 Series 50 aircraft, as represented here, the service units have been installed in the backs of seats. First aid outlets are in the aisle seats in first class, but in the center seats in coach class. The padded headrest is removed and the release button is pushed. The mask nearest the white control knob can be used to administer first aid oxygen. The valve allows the selection of high or low flow for first aid or for supplemental requirements in the event of decompression. Oxygen for first aid from these outlets would first need to be turned on at the main supply valve, which we will be seeing. In some installations where the oxygen service units are in the overhead hat racks, sockets are available for first aid oxygen. The insertion of the connector into the socket turns on the oxygen, while the rate of flow is controlled by an adjustment ring. But the most vital use of oxygen is in the event of decompression. Aircraft are fitted with masks for every passenger to protect them should rapid decompression occur. The doors to the compartments containing these masks are automatically opened in such an event. By pulling the mask to the face, the string which is connected between the mask and a pin in the shutoff valve will pull the pin out, permitting the oxygen to flow. The briefing given to passengers before each flight concerning oxygen masks should explain fully the action that is required by the passenger to start the oxygen to flow. Air pressure and oxygen content is very low at the altitudes flown by modern transport aircraft. To compensate, air must be pumped into the aircraft to inflate the cabin. In the unlikely event of anything happening to cause the cabin to leak, such as a faulty window, the air would rush out, leaving passengers without oxygen to breathe, and they would quickly lose consciousness if they do not understand how to use the oxygen equipment. Had the oxygen been used for first aid in the preceding demonstrations, it would have been necessary to have first turned the oxygen system on at this control valve. The needle on the gauge should indicate 10 pounds per square inch. When the oxygen is no longer required, position the lever to reset, push the button of the bleed valve, and then allow the lever to return to the automatic position. As with every other exercise, the opportunity for trainees to try it for themselves is an essential element in their training. By no means is all the safety training carried on in an expensive simulator. Regular, well-equipped classrooms with student-instructor response system and rear screen projection equipment serve for the teaching of the theory of safety training. Tests are given periodically to determine whether they understand the instruction being given. Training continues, and another day finds the trainees returning for further instruction in the simulator here at the base. Not only do cabin attendants have very comprehensive training before beginning their career of flying, but they are also required by regulations to have annual refresher courses to keep them up to date with changes in equipment and procedure, as well as to determine that they are retaining the knowledge acquired during basic training. Suitable clothing is worn as protection during emergency exercises, which include simulated crashes. While both flight crew and cabin crew are assigned specific emergency duties, they must, however, be familiar with all duties to be able to take over in the event of crew members being injured. All equipment must be secured prior to takeoff and landing, and in particular, emergency equipment which is held in place with quick-release fasteners. Although the fasteners are simple in design, all crew members should practice opening them to achieve quickest possible access to equipment. One of the extinguishers frequently carried aboard aircraft is the water or water glycol extinguisher. As with the life jacket, a cartridge has been inserted in the handle. By twisting the handle clockwise, the cartridge is detonated to pressurize the extinguisher and free the lever. As the jet of water is quite powerful, there is a danger of knocking the burning object away. However, by placing the tip of the finger over the end of the nozzle, it can be made to spray. Water extinguishers are for use on burning wood, paper, or cloth, but should not be used on flammable liquids or electrical fires. We will see why shortly. CO2, however, can be used on flammable liquids and electrical fires, and is, in fact, an excellent extinguishing agent for combination fires. With the nozzle at right angles, the extinguisher is held in a vertical position with one hand on the cylinder while the other triggers the extinguisher like a gun. The extinguisher must never be held by the nozzle, as this part of the unit drops to well below freezing when discharged. Into this pan of burning kerosene, an instructor is demonstrating what should not be done, that is, to use a water extinguisher on a flammable liquid. Instead of putting the fire out, it was being spread, while with the CO2 extinguisher aimed at the base of the fire, a blanket of carbon dioxide displaces the oxygen in the air, and without oxygen, fire cannot burn. Practice in fighting fire helps trainees to overcome their natural fear of fire, which must be conquered if they are to ever be called upon to extinguish cabin fires. Another way to eliminate oxygen is to use a blanket. Care should be taken not to wave the blanket about in the process of putting it over the fire, as this tends to fan the fire, causing it to burn more vigorously. The blanket needs to be pressed firmly in order to successfully smother the fire. As we see, a calm, cool approach would avoid a catastrophe. The hinge design of most aircraft doors is such that it allows the door to swing first inward to one side, then outward and open. The complication of this maneuver is due to the necessity of having a door which will withstand the 8 pounds per square inch or more inside pressure which it encounters at cruising altitudes. A red mark on the handle, when opposite a similar red mark on the fitting, indicates that the door is in the fully locked position. Because of the great pressures exerted on doors caused by pressurization, it is essential that they be properly locked. Although the closing of doors is constantly occurring during normal operations, some junior cabin crew members do not have as much opportunity to become familiar with the operation of the doors as they should. This operation should be included in all training programs. As is fairly common practice, the compartment on the lower half of the door contains the inflatable evacuation chute. However, the chute must be attached to the aircraft with this bar, as the instructor is demonstrating, once the door has been closed in preparation for departure. Now, in the event of an emergency, all that is necessary is to open the door and pull the inflation cord. In an actual emergency, passengers would be given the repeated command to remove shoes, jump, and slide. Here, however, in this training exercise, the trainees are cautioned to sit first, then slide to avoid accidents. In addition to inflatable chutes, there are also non-inflatable chutes, as installed here. To open this emergency exit, the handle is simply pulled inward to an angle of 90 degrees. The door is lifted inward, turned sideways, and then thrown out.
Dan halen we de cover weg voor de non-inflatable slide.
The chute is allowed to drop from its overhead compartment to the ground below and must then be latched into snap locks in the floor of the aircraft. In an actual emergency, 2 strong men would climb down the chute using it as a rope ladder, then pull the chute out to approximately a 45-degree angle for others to slide down. When this exercise is undertaken with trainees, it is advisable to have extra hands to hold the chute. Passengers should not jump, as they would with exits which have inflatable chutes. On some models of aircraft, an emergency door has been installed which deploys the chute automatically. This type of exit is sometimes called a jetscape door. All that is necessary is to remove the transparent cover, which is usually installed, pull down the locking handle, and push the door outward. Being hinged at the bottom, it will fall over and hang downward, dumping and inflating the chute. Red warning markers are painted on the side of this release handle to indicate that the door is not properly locked. If these markings are observed, the captain or the flight engineer must be advised immediately. Since there would exist a real possibility of a failure of the normal intercommunication system during an emergency, a means of giving directions to passengers must be provided. For this purpose, megaphones, or loud hailers as they are also called, are carried. It is a vital requirement for crew members to become familiar with the location of all emergency equipment for the type of aircraft which they are flying. Aside from its duplication of an actual aircraft fuselage, this simulator is capable, as we see, of movement about its longitudinal axis and is powered by this hydraulic system. Training can be conducted with a surprising amount of realism. The trainees take off on a typical nighttime flight, a flight whose sequence of events has been programmed from actual crash records. Certain exits will be blocked, and smoke, which we will not see in the darkness, will fill the cabin. The simulation of a right main gear collapsing causes the simulator to come to rest at an extreme angle. Battery-powered emergency exit lights take over whenever the aircraft electricity is cut or fails. Opening the main cabin door during practice sessions earlier was not too difficult, but now, in the dark, with the aircraft tilted at a sharp angle and filled with smoke, the trainee is finding it extremely difficult to push the heavy door up the incline to get it open. Such difficulties encountered during these exercises give the trainees good reason to take training a lot more seriously. This scene illustrates how essential it is for each crew member to be familiar with his or her emergency duties, to know the exact location and operation of equipment to be used in an emergency, so that they can perform their functions and render proper assistance to a plane load of frightened passengers, many of whom may be children or elderly people. Such a standard of performance can be achieved only by constant and properly supervised realistic training in emergency procedures.